Yeah, so here we are going to see how to generate the frequency modulation wave. So frequency modulation wave is its output will be F naught will be equal to some AC, which is the carrier frequency, into sine, and we vary the carrier frequency, so omega ct plus beta times sine omega mt, where omega m is the message signal frequency and omega c is carrier frequency. Okay, and we expect the carrier frequency to be much larger than message frequency, and beta here is called as modulation index of uh, the frequency modulation curve, and it is simply how much change in the output frequency you are getting divided by the change in the message frequency. Okay, so let us see this. Let us start this again. So I'll first draw my time 0 1, and I'll proceed it like this for some value, and then let me generate a message signal here. So for message signal amplitude, I will leave this curve. Okay, so let this curve be the message signal amplitude, and to sine. So this is message for it as FM. So it is equal to sine. Okay, amplitude. No, I have to take amplitude. So I'm not going to change the row. So dollar there into sine of 2 into pi divided by, let us say, 100 into t. So into this time period here, and let me just drag down to create the entire wave, and let me see this wave. I'll put a curve here, insert a graph here. Okay, so this is the message signal. Okay, so here I will now generate a carrier. So let this represent the what you say, the amplitude of the carrier. So that this be, so this is equal to, this is the same function, so I'll just copy it from here. The only thing I need to change here is the time. It is not t, time is present in the column C, right? Once I do that modification, if I drop down, yeah, so this is my carrier signal. Okay, I need to change the frequency, right? So here I will not be dividing by 100, so let me divide it by a larger value, smaller value, 20. So once I drag it down, it generates a higher frequency, and that frequency is represented be shown by a curve again. So this is the curve to show it. You can see this is my carrier frequency, and this is the message signal frequency. This is the message signal, and this is the carrier, right? Now, amplitude modulated wave, frequency modulated wave, FM output. So for this, I need some beta. So for that beta, let it be point, or let us say just 10 for time being. So what I will do is, this is, let me take the same curve. Okay, so okay, so this is simply the same curve, sine omega t. Okay, let me just copy this. Okay, so the only thing is, instead of having the original frequency, I'll be multiplying that with the beta. If this is not required, amplitude we are not going to change, plus beta. Okay, so in order to get that index, I will be multiplying with this amplitude, message signal amplitude. Okay, into, sorry, need not multiply because already this is multiplied. So I'll be now multiplying that with the message signal itself. So this is the message signal, and and here this is the time period. Okay, so let us see if that works. I've now dragged it. Now let me plot that by inserting the curve, and now here you have the modulation. Okay, all right. So now here you can see for smaller values of your beta. So you can get the proper frequency modulation. So that is what is your frequency modulated curve, and this is how you produce it. Let us say if I want a further this thing, so what I will be doing is I will be using a very high frequency wave and the carrier, and I will be just extending that. Okay, the same thing I'll do here. So it is divided by 10. So once I extend this, this is the frequency modulation curve. You can see now I can use a larger frequency index, so that will give me a more output. So that is what is frequency wave. Hope you have understood. If you have understood, like